In this lesson, we're going to look at graphing piecewise functions. And so with regards to piecewise function, let's kind of define what a piecewise function really means. So a piecewise function is a function in which more than one formula is used to obtain the output. Remember, the output is the y-coordinate. And so it'll look like this. It'll look like, so you have a function, and then you'll have some expression or formula for the first one, and then some expression or formula for the second one, and then some expression or formula for the third one, and so on. I mean, you can have more than three that you see here. And right on the side of that first one, you'll be given the domain for that first formula, and then you'll be given the domain for the second formula and the domain for the third formula, and so on. So it looks something like this. And so before we even go further with this, let me show you. It'll look like this example here. So it'll look like this. All right, so this is a piecewise function. So notice you have this formula, which is defined by this, which has this domain, and the domain is any real number that's less than or equal to 1. And then you have this formula, which is defined when x is greater than 1. All right, so this function has two pieces. So we'll say two pieces. It has two parts, two pieces, this piece and this piece. And so you graph a piecewise function, it'll look something like this. So it's broken into two pieces. You have this piece here, you have this piece here, and you have this piece here. So notice this function here, and we know it's a function because it passes the vertical line test, right? For each x coordinate, there's only one y coordinate, but it's broken into pieces. So I have this piece here, I have this piece here, and I have this piece here based on the domain. So from negative infinity to whatever this x value is, I have this function, and then from this x coordinate to this x coordinate, I have this piece, and then from this x coordinate to infinity, I have this piece. So it looks something like this. So when you graph these, it'll be into parts, into pieces. Okay, so it's not that difficult. It's fairly easy to deal with. So let's look at number one. So in number one, notice that you want to graph this function, and I should put an equal sign here. You want to graph this function, and this function has two parts to it. And the part that you use is based on the domain for that part, for that piece. So if I use any real number less than or equal to 1, then I'm going to use this part of my function. If I use any real number greater than 1, then I'm going to use this part of my function. Okay? All right, now, word of advice here is whenever you graph these functions, all these pieces, always make sure whatever number you see here, that's right here, always make sure you use that number, whether it's included or not, whether there's an equal sign or not. Okay? All right, so here's the way I would do this. Let's start with the first one. All right, let's start with the first one. So I'm going to write y equal, instead of fx, let's just put y. Y equal 1/2 x plus 6. Okay? And I want to find out what my y values are, what my output is when x is less than or equal to 1. Now, it helps if you know that if the domain here was not restricted, it helps for you to know that this is a linear equation, right? So this is going to be a line. All right, so if there was no restriction, like there's restriction here, this would be a line. Okay, so I'm going to use a t-table. All right, now listen carefully. So I'm going to put right here, there is a restriction, and that restriction to my domain, and my domain says that if I'm going to use this piece here, all my values for x must be less than or equal to 1. All right, I see a 1 here, so I'm going to put a 1 right here. Let that be your first value of x. Then let's go ahead and find y. If x is 1, I have 1/2 times 1, 1/2 times 1 plus 6 is going to be what, 6.5? All right, y'all agree 6.5? So that's 6.5, right? If x is, let's say, 0. So remember, I need for you to recognize that without a restriction here, this is a line. So to graph a line, I need 2 points. So let's do one more. So if x is 0, see 0's in here, right? 0's in here. If x is 0, I get 1/2 times 0 plus 6, which is just 6, because half of 0 is 0. 0 plus 6 is 6. All right, now here's how you graph this. So we're graphing that first one now, right? Okay. So I plot these 2 points. Now remember, whatever number you see here, make sure that's the first one you use. Okay, that's going to help you. So I'm going to plot the point 1, 6.5. So 1, 6.5. 6.5 is right here, right? Right in the middle between 6 and 7. Now there's an equal sign. Since there's an equal sign, I'm going to use a closed circle. So it's going to be closed right here. So sometimes it helps to denote this. Let me write it better. Sometimes it denotes to indicate whether it's closed or open, that first point you use. So this is closed, 1, 6.5, right here. So that's closed. Okay. And then my other point I have is 6, 0. Now 6, 0 is on the line as well. And then all you do is draw your ray. Now be careful, don't draw a line, okay? Don't do this. A lot of students, without thinking, they want to draw a line because they see this and they think line. But remember, there's restriction. So your domain must be less than or equal to 1. So you must start here and then go this way. All right? So any real number less than or equal to 1. So this is a graph of that one. So it's actually a ray. This part is a ray. So when my function is equal to this piece here, this is the graph I get. Okay? All right, now let's go to the next one. So now we're going to look at the next one. So now we have y equals -4, and my restriction is that x must be greater than 1. Even though you don't see an equal sign, you must use that number. If you don't, you're probably going to make an error with the graph. All right, now remember, this says that y always equals -4, right? So if x is 1, what does y equal? -4. In fact, if you remember, y equal -4, if there's no restriction right here, y equal -4 is a horizontal line in it. So if I were to graph, just to show you real quick, let me just kind of do this. If I were to graph y equal -4, y equal -4. Do y'all agree y equal -4 just by itself is this, without any restrictions? The domain is all real numbers. So that's this right here, right? Okay. But remember, I'm only interested in what part of my domain. I'm only interested in x greater than 1. So here is 1, so I'm only interested in this part here. So this part I'm not interested in. You see that? Okay. All right. Now let's think about this a little bit further on the graph here. All right, so there is no equal sign. There is no equal sign. So this is going to be an open circle right here. Now remember, this is a horizontal line. So I need another point to graph a line. I need 2 points. I have 1. I need another one. So give me a number that's greater than 1. So a number that's greater than 1. Let's say it's 2. If x is 2, what's my y value? My y value is -4. In fact, do y'all remember, no matter what value you choose for x in that domain here, your y value is always going to be -4. All right, so let's plot that point. So remember, when x is 1, I cannot include it, so that's an open circle. So here's 1, -4, open circle. All right, here's 2, -4. 2, -4 is in the domain, so that's a dot grid, that's a closed circle. And then you just draw your graph. And that's a ray as well, but going this way. Okay? All right, now make sure you draw your arrow. You see I have some dark grids here. So let me kind of use a blue pen here to make it a little bit darker. So that's an open, and then that is closed like this. Okay? All right, there's my graph. All right, there's the graph. So notice it's important you recognize that y equal this is a line, y equal this is a line without any domain, without looking at this, okay? But now we have to look at this right here. So I've got to choose I got to choose all the values of x that are less than 1. So that breaks this line into this piece only. Okay, because remember, all right, remember this. If you graph y equals 1/2 x plus 6 without the domain being restricted, if x is 0, you get 6. If x is -2, you're going to get 1/2 times -2 is a -1, so you get 5, right? So if you look at that part, 0, 6 is here, -2, 5 is here. and then you get this piece, this graph. But remember, I'm restricting my domain, so I only want to include only the part that's less than 1. So here's 1 right here. So I need to take away this part right here. So I need to take away that part and only include this. Okay? So you see that's where, so I only want to include x is less than or equal to 1. So you see this piece right here? That's what you see here. Okay? So it's very important. It's very important that you think like this. Those students that draw a line like this, whenever they draw a line, they're not really thinking about what this means right here. All right. And also, if you do draw a line, just to show you what's going to happen, what some students do is this, and so I don't want you doing that mistake, but what some students do is this. They'll do this, okay? And then they'll draw this right here, and then they realize, remember, you're told this is a function in it. So this is a function, so it's got to pass a vertical line test. Well, notice nowhere does it pass a vertical line test. Okay, so something's wrong here. The way you've drawn it is incorrect. Now, if you look at the correct graph, notice that this does pass a vertical line test. Intersects the graph once each time. And you may say, what about here? Well, remember, that's closed, that's open, so we're good. When x is 1, I only have one y value, and that's 6.5. This is open, so I cannot use it. You remember that was a lesson we did probably about a week and a half ago where you had open and closed circles? All right, so that's where that comes in as well. This is not part of your function. This is the closed circle right here. Okay? All right. So let's look at another one, and then we'll get a little bit easier with the more we do. So the domain here is very important with how we graph this. Okay? So 1 piece, 2 pieces. 1 piece, 2 pieces. Okay? All right, let's look at number 2. So number 2, we have this. All right, so here's number 2. So my function has 2 pieces. 2 pieces. The first one is, it has this formula, absolute value of x, but my domain is restricted to this. So if x is less than 4, then I'm going to use this. If x is greater than or equal to 4, then I'm going to use this piece. Okay? So let's do each one individually. So the first thing I would do is I would write the first one. Y equals absolute value of x, and remember x is less than 4. Whatever number you see here is that first number you start with. That's important. That first number you start with. All right, so listen carefully. So x is 4. There's no equal sign. There's no equal sign, so I'm going to put the word open. So that way when I plot that point, it's going to be an open circle. All right, so that's important to do. So since there's no equal sign, I'm going to put an open. I'm going to write the word open, and when I plot that point, I'm going to put an open circle. All right, now when x is 4, the absolute value of 4 is 4, right? So I get the point 4, 4. So right now, if I go and I plot that point, I just want to show you, when I plot that point, I'm going to put an open circle here at 4, 4. Okay? Now, 4 was not in the domain. Now let's pick a number less than 4, like let's say 3. Y'all agree that 3 is in the domain, right? So 3, when x is 3, the absolute value of 3 is 3. So I plot the point 3, 3. So that's this. Now be careful. Some students, what they're going to do is, now watch my pen. They want to draw a line like this. Now be careful. The absolute value is not a line, right? Don't draw a line like this. It is not this. It's not a ray. Okay, it's not a line. Remember, this absolute value of x is that v is a shape of a v. Remember that? The shape of a v. So you have to remember that that the absolute value of x, let me put that here. Y equal the absolute value of x has this shape. Okay, shape of a v. So you have to remember now that we're going to need a few more points than just these 2, because that's not a line. So remember, to graph a line, I just need 2 points. This is absolute value of v, the absolute value of x. So that shape is a v. So let's do a few more. So let's say x is 0. The absolute value of 0. See, 0's in here, isn't it? Okay. So 0, absolute value 0, 0. So I plot the point 0, 0 right here. See that? Let's do a negative number. Let's do the let x be -2, because -2 is in here, isn't it? -2 is in here. -2 is less than 4. The absolute value of -2 is a +2. And so notice -2, +2 is here, and there's your v that you see. So watch what happens. Okay, so I'm going to connect this like this, and then it's going to go up like this. See that? So, so instead of, see that v? You see that v right here? But remember, it's not the whole v in it because this is restricted. You're only looking at the part. See this 4 right here? You're only looking at the part that's less than 4. Now, I want to remind you what the absolute value of x looks like, and that helps in your mind to think about this. So here is the absolute value of x, y equal absolute value of x. So the absolute value of x, when x is 0, absolute value of 0 is 0. When x is 2, absolute value of 2 is 2. When x is -2, the absolute value of 2 is 2. So that looks like this. This is the absolute value of x when you did not have any restriction to the domain. But this says I only want to look at the part, I only want the part that's less than 4. So you see this square 4 right here. So I got to take away this piece here. And that is the part right here. That part is what you see here. Okay? All right, so that's the idea. That's the idea. You're not graphing all of absolute value v, you're only graphing part of it. And you're only graphing the part that's less than 4. All right, now let's look at the next one. So now we're going to look at y equal 2. And this time, x is greater than or equal to 4. All right, so let's do a t-table. It helps to do a t-table. Whatever number you see here is what you put here. So if x is 4, this says that y has to equal what number? See, there's no variable in it. So that means that y is always equal to what? 2. Now, there's an equal sign, so there's going to be closed. So when I plot that point, I'm going to put a closed circle. So 4, 2 is right here. Notice closed. And then this is a line, a horizontal line, or in this case, part of a horizontal line. So I need one more x value that's greater than or equal to 4. Let's say 5. If x is 5, this says y has to equal what? 2. So let's plot the point 5, 2. So 5, 2 looks like this. And now we have enough to draw our ray. So this is a graph right here. All right. So notice this piece here corresponds to this. X is less than 4. See that? Here's 4. X is less than 4, so that's my domain. And then the domain here, x is greater than or equal to 4, that's this part here. See that? Okay, so there's your graph. That's number 2. All right, so it helps to understand how to graph these things in the past where the domain was not restricted. All right, let's look at number 3. All right, so here's number 3. So I want you to first of all recognize you're going to have 3 pieces to that function, 3 pieces to this graph. You have this piece, and this piece. So this piece, whenever you use y equal -x, that's going to be when x is less than or equal to -4. So that's the domain for this part. Here's the domain for this part, and here's the domain for this part. Now, I want you to recognize that if none of this was here, if none of this domain was here, and you're only looking at each part individually, all these would be lines, right? A line, a line, a line. These are all linear. But now we're restricting it, though. All right, so it's not going to be 2 arrows. Don't draw 2 arrows. Okay. All right, because the fact that these are restricted, these are not really lines anymore. All right, now let's go to the first one. So y equal -x. Y equal -x, and then here's my domain. X is less than or equal to -4. So that's going to be the first we're gonna graph. So we're going to do a t-table, and I need you to remember what the first x you're going to use is whatever you see here, whether there's an equal sign or not. There's an equal sign here, so that's going to be a closed. That means it's going to be closed. So when x is -4, this says this: y will equal the opposite of x, which is a -4. The opposite of a -4 is a +4. All right, and that's going to be closed, right? Closed because of the equal sign. And since this is a line without the restriction, if I was just looking at all real numbers, this would be a line, so I need one more point. One more point is all I need. But I got to use a number that's less than or equal to -4, though, because it's got to be in this domain. So let's say 0. I'm sorry, 0 is not in here. Let's say negative 6. Negative 6, right? So let's use negative 6. When x is negative 6, I get y equal the opposite of a negative 6. And the opposite of negative 6 is a positive 6. All right, so let's plot those 2 points. So 4, negative 4, that's a negative. Negative 4, 4. Negative 4, 4 is right here, and it's closed because that's an equal sign right here. And then the other point is negative 6, 6. Negative 6, 6, which is here. All right, right here. And now let's go ahead and draw that ray. All right, so look like this. Look like this right here. So there's your graph. Okay, that's the graph. All right, you see right here? All right. Now let's do the next one. So the next one says y equals, and do not see this right here. Make sure it stops at that closed circle. It's got to stop at the closed circle. So you'll be using a pencil. So just go ahead and erase it. So I just went ahead and liquid papered it. All right, let's get the next one. So the next one says y equals x plus 2. So let's graph that piece, x plus 2. But remember, our restriction of the domain is from negative 4 to 0. Notice there's no equal sign, and there is an equal sign. All right, so let's talk about what to do when you see that instead. Negative 4 is less than x is less than or equal to 0. Okay, so without the restriction, you remember this is linear, so that's a line, right? Okay, but there is a restriction, and my domain only exists between negative 4 and 4. So in other words, my domain is only from negative 4 to 0, 0. So from here to here, this is 0. So that's your domain. So your graph, this graph is only going to be between negative 4 and 0. Okay? The graph is only between negative 4 and 0. See right here? The graph of this was from negative infinity to negative 4. See that? Negative infinity to negative 4. Let's see right here? Negative infinity to negative 4. That's where your graph was. This graph is going to be from negative 4 to 0. That's what it says, negative 4 to 0. All right, so let's plot some points. So without the restriction, this would be a line, so you need 2 points. And the 2 points will be these two right here. You must use whatever number you see. I see a negative 4 and I see a 0. So let's start with negative 4. Negative 4, there is no equal sign, right? So that's going to be open. And so when x is negative 4, look at what you have. I have y equals negative 4 plus 2, which is a negative 2. So I'm going to plot that point, negative 4, negative 2, but I'm going to put an open circle because there's no equal sign. All right, so negative 4, negative 2, which is right here. See this? I put a circle, open circle. And now let's use 0. You got to use whatever numbers you see. I see a 0 here. So this piece, remember, negative 4 to 0 is bounded. So there's a lower bound and an upper bound right here. Okay? So 0. If x is 0, now notice there is an equal sign, right? So that'll be closed. That's going to be closed. There is an equal sign. So x is 0, I get y equal 0 plus 2. X is 0. 0 plus 2, which is 2. So I'm going to plot the point 0, 2. And 0, 2 is right here. Closed circle. And then I just connect those two circles, those 2 points, and I get this, right? No arrows, right? No arrows because it's only bounded between negative 4 and 0. So that's that piece. So this piece right here, y equal x plus 2, when x is between negative 4 and 0, is this right here. Okay? And then let's do this one now. So the next one, the third one, is y equals negative 1/2 x plus 3. And this time our restriction is that x must be greater than 0. So remember, this is without the restriction. If you just looked at just graphing this, that's a line, right? So you need 2 points, but I am restricting it, so I'm going to be looking at part of that line. And the part I'm looking at is any x that's greater than 0. But remember, when using a t-table, you must use that number that you see. I see a 0. There is no equal sign, so I'm going to put the word open here. So that way when I plot that point, I'm going to put an open circle. So when x is 0, I get y equals negative 1/2 times 0 plus 3. Negative 1/2 times 0 is 0. 0 plus 3 is 3. So I'll plot the point 0, 3. So here is 0, 3 right here. 0, 3. That's the y-intercept. So that's the point on the y-axis. Except it's open, right? It's open. All right. Now, now remember, I need one more point. This without the restriction, this will be a line. To graph a line, I need 2 points. But to graph this, and this is going to be a ray, by the way. It'll be a ray. Actually, the slope is negative, so it'll be going down. It'll be a ray, and I need one more point. So I got to pick a value of x that's greater than 0. So let's say 2. I'm going to pick 2 because, see, I'm multiplying x by negative 1/2. So I want this to be a nice number. So I'm going to use 2. So if x is 2, I get y equal negative 1/2 times 2 plus 3. And remember, I chose a nice number because I was multiplying it by negative 1/2. So I chose an even number. So a negative 1/2 times 2 would be a negative 1. Negative 1 plus 3 is 2. So I'm plot the point 2, 2, which is right here. All right, close right there because 2 is in that domain. And then you just draw your ray. And make sure you draw a ray and not a line, okay? Looks like this. Okay, make sure you draw your arrows. Now don't extend it because then it's no longer a function. See right here, if you extend it, then obviously it fails the vertical line test. Okay, so there are your pieces. So always go back and double check. So check your domain. So notice this piece has to be in the domain that's less than negative 4. So you see here's negative 4, right? What? See right here? Here's negative 4. And so you have this piece. You see that? So that piece corresponds to this. Then from here to where this is, from negative 4 to 0, you have this piece. See, negative 4 to 0. See, always make sure you look at that. And then from 0 to infinity, if this is going towards infinity, you have this piece. Okay? All right, and that's it. All right, that's how you do this. Not difficult at all. It's just you thinking about this in terms of, well, what is a piecewise function? Well, a piecewise function is a function where the graph is actually graphed in pieces. And notice that these are these all have different domains. So this piece here is from negative infinity to negative 4, and then this is from negative 4 to 0, and this is from 0 to infinity. All right, and notice wherever they overlap. See right here, these two graphs right here overlap here. Notice one's closed, one's open. They cannot both be closed because then it would no longer be a function. If they were closed, that would mean for this x value, there are two different y values. All right, same thing here. See where they overlap here? One is closed, one's not. So in terms of the function, the x-intercept for that function is where it's closed. So this is the x-intercept of this function because that's where it's closed. I didn't mean x-intercept, I mean y-intercept. This is a y-intercept of that function because that's where on the y-axis the point's closed. This is not the y-intercept because that's open. All right, so keep that in mind. All right, so that's number 3. Let's look at number 4. All right, so that's number 3. Let's do another one, number 4. All right, this is number 4 right here. So you have number 4, you have this function, this piecewise function, and it has 3 parts to it. Y equals 3x if this is your domain, x is less than 0. If the domain is between 0 and 3, including 0 and including 3, see those equal signs right here? Then it's y equals 4. And if your value of x is greater than 3, then you're going to use x squared. Now, I went ahead and I scaled this differently than the others. So notice in all the others, it was scaled 1, 2, 3, and so on. This I scaled differently because of that x squared right here. And you'll see why I had to scale a little bit like this. So each of those little tick marks are multiples of 2. All right. And let's go ahead and do the first one. So first one is y equals 3x, and then the restriction is that x must be less than 0. So there's no restriction. You know that this is a line, right? Y equals 3x is a line. To graph a line, you need 2 points. So now that you see a restriction, you still need 2 points. You still need 2 points. Except, remember, you're always going to use this number you see. So I'm going to use 0. That's going to be my first number I'm going to use, 0. There's no equal sign, right? So you know what you're going to write. You're going to write the word open. And then if x is 0, you have y equals 3 times 0, because 3x, x is 0, and 3 times 0 is 0, so y is 0. So now we're going to plot the point 0, 0, which happens to be at the origin, right? And it's going to be an open circle, okay? And then I need one more point, so I'm going to pick another value of x that's in this domain, though, so it's less than 0. So let's say negative 2, negative 2. If x is negative 2, I get y equals 3 times a negative 2. Well, 3 times a negative 2 is a negative 6. So I'm going to plot the point negative 2, negative 6. So here's negative 2. So negative 2. This is negative 2, negative 4, negative 6. So here's the point right here. Negative 2, negative 6. And notice the only word open was here because negative 2 is in the domain. 0 was not in the domain, so that's why I put the word open. Make sure you understand that. So make sure you understand, well, why are you putting an open here and a closed here? I put an open here because when x is 0, 0 is not in this domain, but I still have to use 0. So that's, see, there's no equal sign. So that's why I'm using the word open, because when I plot that point, I'm going to have to put an open circle. Okay? And then remember, without the restriction, this is a line. Since there is a restriction, then it's going to be a ray. So this is the end point of that ray right here. So then you just connect those like this, and there is this piece of my function. So notice x is less than 0. So from negative infinity to 0, from negative infinity to 0, there's my piece right here. Okay? That's y equals 3x right here. Now, next part is from 0 to negative 3. So here's 0, and here's 3. 3 right here. So 3 is between 2 and 4, right? Okay. Now remember how we dealt with this. So you have to use 0 and you have to use 3. Okay, whatever you see here, you're going to use those points. All right, so let's do the next one. So y equals 4. Y equals 4. And then my restriction is 0 is less than x is less than or equal to 3. All right. Now remember, y equals 4 without the restrictions is a horizontal line, right? It's a horizontal line, but there's a restriction, and there's a lower bound and an upper bound, so it's actually a segment. And you're going to see what I mean by that. So if x is 0, you're going to use 0 and you're going to use 3. 0 and 3. Notice both of those have equal symbols, right? So both of those are closed. So closed, closed. Okay? If x is 0, this says that y, so if x is 0, this says that y has to equal what? Y has to equal 4. If x is 3, this says y has to equal what? Y has to equal 4. So those are my 2 points. So let's plot 0, 4 and 3, 4. So 0, 4 is here, closed circle. 3, 4, this is 3 right here. 3, 4 is here, closed circle. And then I draw my segment. Okay? So remember this, a segment has an endpoint and another endpoint. So it has 2 endpoints. A ray has one endpoint and then an arrow. All right. So that's this piece here that I've drawn corresponds to y equal 3x. And then this piece here that I've drawn corresponds to y equal 4 between 0 and 3. See, 0 and 3. Now let's do f of x equal x squared. All right, so the next one is y equal x squared, and then this time x is greater than 3. Okay, so even though you don't see an equal sign, you must use that number. So when x is 3, I get y equal 3 squared. Well, what is y equal 3 squared? Y equal 3 squared is 9. But that's an open circle, right? So you can put the word open here. Now remember, this is a parabola. So remember, y equal x squared is a parabola. So you have to remember that. You have to remember the shape of a parabola. So remember, y equal x squared looks like this, right? Shape of a parabola. But we have a restriction here. So this restriction will be part of a parabola. So we're going to take away part of it and only look at part. That's what that means. Okay. Now, let's look at another number. So give me another number that's greater than 3. Let's use the next integer. The next integer is 4. So when x is 4, I get y equal 4 squared, which is 16. All right? So far, So for a half, I have 3, 9, and 4, 16. So let me show you what that looks like. So here's 3, 9. So 3, 9 is about here, right? Right, oops, it's between 8 and 10. So let me put it here instead. So this is where 3, 9 is, right here. But remember, it's open, correct? Right here. See, it's open. Then 4, 16, right here, 12, 14, 16. 416 is right here. So that is closed. And if I did one more, let's say x is 5, I get y equal, oops, sorry, y equal 5 squared, which is 25, but I don't have enough room here. So 525 will be, see, this is 5 right here, right? 525 would be somewhere way up here. So the graph here would look something, now it's not a ray, so be careful. But it'll look something like, it should be curved. Now it's hard to do. This one's hard to do to make it look curved. It's hard to make it look curved because I don't have enough space up here. All right. So that's not a good picture of x squared, because x squared is supposed to look, see, y equal x squared looks like a parabola. So basically you're just looking at this piece here. So which is supposed to be curved. See that? It's supposed to be curved. But since the tick marks, since those little marks are so close together, it's hard to see this. So I'm trying to make it look a little bit curvier, if you want to use that word. It's not supposed to be a line, so I'm trying to make it look more curved. All right. Okay, so that's the best I could do with this based on the fact that I didn't have enough space up here. All right. Okay, so that is number 4. That's number 4. So notice the different pieces. First piece, second piece, and third piece. Okay? And notice this is the graph of that third piece is supposed to look something like this right here. Okay? All right, that's number 4. Let's look at number 5. So here's number 5. All right, so I have, this function has 2 pieces. I see that x squared again, so that, remember, if there was no restriction to my domain, then if the domain was all real numbers, then this would be a parabola. Same thing here. If the domain was all real numbers, this would be a line. But I'm restricting my domain here. All right, so this function is defined into 2 pieces, this part and this part, based on the domain. So let's do the first one. So the first one is y equal x squared if x is less than 0. So just like we talked about before, since whatever number you see here, you must use it. And since there's no equal sign, it's going to be an open circle. All right, now remember, this is not a line because remember, that's a parabola. If the domain was all real numbers, this would be a parabola, but I'm restricting my domain, so I'm only using part of this parabola. So if x is 0, this is going to be open since there's no equal sign. When x is 0, I get I keep doing y squared. Y equals 0 squared, which is 0, right? And then if x is, got to use a number less than 0, so if x is negative 1, I get y equal negative 1 squared, which is a positive 1. Now remember, since that's the problem, I need a few more points. So if x is negative 2, I get y equal negative 2 squared, which is 4. If x is negative 3, I get y equal negative 3 squared, which is 9. And that's about as far as I can go because it goes up to 11. All right, so let's plot those points and see what we get. So open circle here, right? So make sure you put an open circle at the origin, just like this. And then negative 1, 1, negative 2, 4, negative 3, 9. And there's your part of your problem. Remember that that's supposed to be curved. So see, you can see the curve better here than you could have here, right? See, you can see the curve better here. Here than you could here. Okay? So there's that part of that parabola. So you're looking part of that parabola, and that's a part that's, so the part of parabola you're looking at is a part that in which x is less than 0. All right, now let's do the next one. So now we're going to look at the domain that's greater than 0, so where x is greater than 0. So this is the piece. This right here is the piece right here. This is a piece if x is less than 0. See, here's 0. X is less than 0. Now let's look at the piece of the function where x is greater than or equal to 0. So let's see what it looks like on this side. All right, so that's going to be this one right here, y equals x minus 3 if x is greater than or equal to 0. Notice there's an equal sign. Again, you must use that point, that number you see here. So if x is 0, that's going to be closed because of the equal sign. Remember, this is a line, right? So if the domain was all real numbers, so there's no restriction, the domain would be all real numbers, so you'd have a line. To graph a line, you need 2 points. That's all you need. So since I'm restricting it, I'm still going to use 2 points. But I can only use the x values that are in this domain. So if x is 0, there's an equal sign, closed. So if x is 0, I get y equal 0 minus 3, which is a negative 3. I need one more. Another value of x is greater than or equal to 0, let's say 2. If x is 2, I get y equal 2 minus 3, which is a negative 1. All right, so 0, negative 3. 0, negative 3 is going to be closed because I'm including 0 here. There's an equal sign. So 0, negative 3, closed. And 2, negative 1 right here, closed as well because 2 is in this domain. And so you just draw your ray, and this is it. That is your graph. See that? So first piece, second piece, right here. And remember, this is a function, right? So notice it does pass the vertical line test. It does pass the vertical line test. All right, so first piece corresponds to this one right here. Second piece corresponds to this one. So first piece corresponds to this. Second piece corresponds to this. All right, that's it. Now let's look at another. Number 6. See, it's not that bad. Once you do a few, it gets a little bit easier. All right, let's get this one. So number 6, again, you have this function has 2 pieces. You have an x plus 2 if x is less than or equal to negative 1, and you have an x cube if x is greater than negative 1. So don't let that cube throw you off. It's not that bad. So let's do each piece individually. So let's get the first one. Y equal x plus 2 when x is less than or equal to negative 1. So remember, if there was no restriction, if the domain was all real numbers, this will be a line. But I have a restriction, right? So it's going to be a ray instead in this case. But I'm still going to use 2 points. All I need are 2 points. And one of the x values you're going to use will be this number, regardless of whether you see an equal sign or not. So I'm going to use x equal negative 1. Since there is an equal sign, when I plot that point, it's going to be a closed circle. So when x is negative 1, wherever you see the variable x, substitute negative 1. I get y equal negative 1 plus 2, which is 1. All right, and I need one more value of x. So if x is, let's say, give me a value that's less than or equal to negative 1. So let's say negative 3, right? So if x is negative 3, I get y equal negative 3 plus 2, which is negative 1. So now let's plot those 2 points. So negative 1, 1 is right here, closed circle. So put a dot, right? And negative 3, negative 1 is right here, okay? And so here's your ray. It's not a line. Don't draw a line because you know you're restricting it, okay? So be careful. Always think about your restriction. What are my x values? And see, if you drew a line, it would no longer be correct because your domain for that first piece has to be less than or equal to negative 1. So here's where x equal negative 1 here, right? So you can't have any part of that graph on this side. It's got to be only on this side. See that? Less than negative 1 and only this side. So always think like this. Always use some ruler or something, clear ruler, to make sure you don't see anything in this ruler part here. Okay? All right. So help yourself like this. All right, and then the next one, y equal x cubed if x is greater than negative 1. All right, now y equal x cubed, let me just kind of show you what y equal x cubed looks like, just to show you. So if I were to graph y equal x cubed, just y equal x cubed, without even looking at any restrictions, let me just show you. So here's y equal x cubed. So that's a polynomial, and the domain is going to be all real numbers, y equal x cubed. So if I pick a value of x, let's say 0, 0 cubed is 0, right? If x is 1 cubed is 1. Y'all agree? If x is negative 1, negative 1 cubed is a negative 1. If x is 2, 2 cubed is 8, right? If x is negative 2, negative 2 cubed is a negative 8, and so on. So if you did 3, 3 cubed is 27, which I don't have a 27 up here. So I would actually need to only use these right here. If x is negative 3 cubed would be a negative 27. Again, I don't have a negative 27. So I'm just going to plot these points right here because that's all I can plot in this plane that I have. So let's plot the point 0, 0. I want to show you what the graph's going to look like. 0, 0, 1, 1, negative 1, negative 1. See that? And then 2, 8, 2, 8, and then negative 2, negative 8. So the graph of x cubed looks like this. It's a curve, and looks something like this. And on this side, it'll look like this. Okay? So that is the graph of y equal x cubed. Y equal x cubed. So around that origin right here is where it's kind of flat. And then all of a sudden it increases quite a bit because you're cubing x. And it decreases quite a bit here because you're cubing x as well. Okay? All right. Now, that is y cubed. So when we graph this, though, when we graph, and remember, this is y equal x cubed when the domain is from negative infinity to infinity, when the domain is all real numbers, right? That's what this is. But in this problem here, right here, I'm restricting the domain. I'm only want to look at the part that's greater than negative 1. So if you go back to this right here, I'm only looking at the part that's greater than negative 1, right? So here's where negative 1 is. So I'm only looking at this piece here. So when I graph this right here, I don't want this part that's in that yellow part. See that? I got to take this piece away. All right? So here's what you do. So, all right, so I have to use this number here, negative 1. Even though there's no equal sign, I still have to use it, except I'm putting an open circle. So when x is negative 1, I have negative 1 cubed, which is negative 1. Negative 1 times negative 1 times negative 1. Now, pick another number greater than negative 1. So let's say 0. When x is 0, I get 0 cubed, which is 0. When x is 1, I get 1 cubed, which is 1. When x is 2, I get 2 cubed, which is 8, right? And so on. So 3 will be too big because I don't have enough space up here. So here's what I have. Let's plot what I have. I have negative 1, which is going to be open. And I want you to think about this. You know it cannot be closed, right? Because this is already closed. See, there's a closed, and then that has to be open. Because when x is negative 1, you can't have two y values. So they both cannot be closed. So that's why you see one is closed, one is open. Okay, the closed is part of the graph, the open is not part of the graph. All right, 0, 0 is here, closed circle. 1, 1 is here, closed circle. And then 2, 8 is here, closed circle. And so here's what you get. All right, so you get this piece here, kind of looks like this. And then it rises quite a bit because you're cubing x like that. So you see this piece here, that piece here, I'm hoping you see it. That piece here, see this piece right here? That piece right here is actually, let me show you, is actually this piece here. Let me do highlight it. Watch, it's this piece here. So the piece I've drawn here is this right here. Okay, see that? That is this. All right. So remember a while ago I said, well, if y equal x cubed, when you look at the domain being all real numbers, is this. But if you're looking at just a part that's greater than negative 1, here's where x equals negative 1. So you're only looking at this piece here. So this piece is what you see here. Okay. So what's in the highlighted ruler right here, the yellow part, you don't graph. So that's why you don't see anything here. All right, so that is number 6, and let's do one more. So one more, and let's look at number 7. Number 7. All right, so number 7, I have this piecewise function. So this function is going to equal to 6 if x is less than or equal to negative 2. This function will equal 3 if x is between negative 2 and 3. And this function is going to equal 2x minus 3 if x is greater than or equal to 3. So when I graph this function, I'm going to have 3 pieces. First piece, second piece, third piece. All right, so let's look at the first one. So y equal 6. And here's my restriction. X must be less than or equal to negative 2. So remember, y equals 6 without restriction is that horizontal line, right? But I have a restriction here. I'm only going to use a part that's less than or equal to negative 2. So when I do a t-table, I must use this number I see. There's an equal sign, so it'll be closed. And so when x is negative 2, this says y has to equal 6. And then to graph a line, I need 2 points. So give me another point. So another point less than another value of x less than or equal to negative 2 would be, let's say, negative 4. When x is negative 4, I get y 6 as well in it. All right, so let's graph this piece first. All right, so negative 2, 6, negative 2, 6, closed circle. So negative 2, 6 is here. And then negative 4, 6 is here. All right, now be careful. Don't draw a line, right? Because y equals 6, my domain is being restricted. So don't draw a line. You're only looking at the part that's less than or equal to negative 2. So here's where x equals negative 2 right here. See this? So you use a rule if you got to. And notice that when you graph y equals 6, you can only use, the graph can only occur in this piece here, in this part of my plane right here. Okay? That's important you see that. All right, so then the graph is this. It's just a ray where this is the endpoint and your ray is going to the left like this. Okay, make sure you draw an arrow. All right, so from negative infinity, remember, x is less than negative 2. Let me just remind you. X is less than negative 2 means negative infinity to negative 2 with a bracket, right? So notice from negative infinity to negative 2, there's your graph, y equals 6. So all these y values are 6. Let's look at the next one, y equals 3. Y equals 3. Now notice for that one, you have you're bounded here. You have a lower bound and an upper bound. So you have negative 2 is less than x, it's less than 3. So when I graph this one, now remember, if there was no restriction, that would be a horizontal line, right? Y equals 3 is a horizontal line, like this. But the restriction, so notice when I graph it, I only want to go from x equal negative 2, see the ruler, to x equal 3 right here. So this graph is only going to exist in this region right here, from negative 2 to 3. All right, so when I do a t-table, I've got to use these two numbers I see, negative 2. Notice there's no equal sign, so that's going to be open. And I got to use this one as well. 3, notice no equal sign, so it'll be open as well. So when x is negative 2, this says y has to equal what? 3. When x is 3, this says y has to equal what? 3. And so I'll plot those 2 points. Negative 2, 3 is right here, open circle. And then 3, 3 is right here, open circle. And then I shade it in. So you have this segment with the endpoints not being part of the graph. Those are open circles. So notice from negative 2 to 3, from negative 2 to 3, I have this horizontal segment. And then next one is y equals 2x minus 3. Y equals 2x minus 3. And this time my domain's restricted to x is greater than or equal to 3. So whatever number you see here is what you use. Now remember, if there was no restriction, if you were just looking at all real numbers, this would be a line that would rise because my slope is positive, positive 2. But I have a restriction, so I'm only using part of that line, okay? And the part of the line I'm using is the part in which x is greater than 3. So when I graph this piece, it's only going to exist in this region right here. It's only going to exist in this region. So if x is greater than or equal to 3, I have to use this number 3. And since there's an equal sign, when I plot that point, I'm going to make it closed. And when x is 3, here's what I get. I get y equal 2 times 3 minus 3. 2 times 3 is 6. 6 minus 3 is 3. So I plot the point 3, 3. All right, well, that one wasn't a good one because it overlaps with this one. So let me change it real quick. I apologize. Let me change it real quick. I'm going to change it to 2x minus 8. I'm going to change it to 2x minus 8 because I didn't want the two numbers to overlap. So this will be 2x minus 8. All right, I apologize for that. So if x is, so let's just change this right here. So closed, when x is 3, I get 2 times 3 minus 8. Okay, 2 times 3 minus 8. So 6 minus 8 is negative 2. So plot the point 3, negative 2. 3, negative 2, which is right here. All right, closed circle, right? Closed circle. All right, closed circle. And then I need one more number that's greater than or equal to 3. So let's say 4. So if x is 4, I get y equal 2 times 4 minus 8. 2 times 4 is 8. 8 minus 8 is 0. So I'm going to plot the point 4, 0. So 4, 0 is on the x-axis. That's right here. And then I draw that ray, and this is what I get. All right, this is what I get right here. All right, so they're the pieces. Now remember, I went back and I changed 2x minus 8. All right, I changed it to that because when I used the 3, the closed circle would have been above the open circle, and I didn't want to confuse you at this point. It's you can have this. It is possible it is possible where an open circle one piece is the same as a closed circle in another piece. Okay, but I didn't want to confuse you at this point, so I just went ahead and I changed it. Okay, so that is the graph of the function, the piecewise function f of x equals 6 when x is less than or equal to negative 2, f of x equals 3 when x is between negative 2 and 3, that's this piece here, and then 2x minus 8 is this piece here. Okay, all right, so that should help you with that part of the section where they're going to ask you to graph piecewise functions.